disclaimer pun is intended when I put this title, Let Us Not Rest. So that's the rough agenda. So we're going to be talking about the state of rest, and I'll come to the introduction part, what we're going to talk about. I do have demo in the end, and if you have any questions during the presentation, yeah, you're more than welcome to ask. But we'll also have questions towards the end. Just a warning, I've used quite a lot of analogies, metaphors, pictures, because I believe the concept is new and I'm challenging the status quo. So I need some visual help to actually deliver the message. So the good thing about analogy is everybody understands. The bad thing about it, it will break if you ask questions beyond, right? So in case you're getting stuck with analogy, you can let people know, or you can raise your hand. Yeah, that's just an analogy warning. Right, so I'm gonna start with this. Right, it's going to be a 4-quadrant. Right, you have server and your client as an individual, and you have server seen by server as in the self-image, what server thinks of itself, and what client thinks of itself as the horizontal, and then how the server sees the client and how the client sees the server, right? You get the idea? Yeah? Quiet? Okay. So this is how a server sees itself, right? It's all powerful, it can stop time, it can rewind, you do have time, travel and all that. That's the image server has. I mean, that's the image the client has, right? It's beautiful, it's a piece of art, it can't be reproduced. Fair enough? Agree? Disagree? Agree? Okay. That's all fine, right? That's our own self-image. The problem comes when, what does the server think of a client? That's what it thinks, right? Client are like a bunch of kids. They always want more. They want the same data in 100 different shapes and forms. Why can't they ask in one shot? Do you agree in your development, right? You will have one endpoint that's some part of your screen and a different version of the same endpoint for a different version of the screen. That happens, right? So that's how a server sees the client. And then the client sees server like that, right? He's a kid with a bunch of toys. Without me, he's useless, right? That's how a client thinks. I said that for a reason. The reason is because no matter what you do, you can come front if you're not seeing pictures. No matter what you do, it is actually an apple to orange, right? No matter what kind of an isomorphic stack that you have. You can argue I'll have one JavaScript, the same thing is going to run on the server, but it's still not apple to apple. And what do we have to make these two desperate, dependent, with an impedance mismatch talk? And can I mind? Oh, good. Is REST, right? And we've had multiple things in the past. We've had SOAP, Corba, blah, 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 blah. But today, the default way in which your client and your server talks is REST. And what is REST based on? It is based on a real mature platform, like the web as we know it. And if you're not seeing these principles, yeah. Raise your hand, how many of you use REST in your day-to-day life? Like pretty much everyone. So I'm challenging all. Right? So that's good, right? And what happens on the client side? You will have some version of this in your client app. You'll have an MVC, or you'll have an MVVM, or we'll have an MVP. That's what is going on in the client app. But what is really going on is that have people felt this when you're developing? It's like a lockstep, right? As a client, if you're making requests, it depends on the browser implementation, how many things it can actually fire concurrently to the server. So you should go one after the other, no matter what, right? Yes? Okay. And then what does a client do? It has to do some kind of a transformation, right? Have you written an app where There is an endpoint. The endpoint is exactly painted in the UI. Raise your hand if you have done that ever. Is the question clear? I have an endpoint that is exposed by my server. As a client, I just consume, and that is exactly the format in which I need to render. Any non-trivial app. I mean, this can be interactive. So have you guys felt that pain that you need to transform? No? Yes. Okay.
In case, I think all the dictator things, the data format that we expect, we need to do some management and then only we can use it.
Yeah, okay. So hold on to that thought. Right, let's say in the end, what you typically need is some object representation, roughly like the JSON here. Not exactly JSON, but some object in your JavaScript or whatever language that you're writing in, which is ultimately JavaScript in your browser. You will have that representation and you will use that to paint a not so trivial, but a very tiny page in your entire app. Right, this is your normal picture. So this is what, people start with an ambition of a pure RESTful endpoint. But if you want to select, what fields I want, if you want to do filtering, if you want to do anything non-trivial, your endpoint will look like this. And this is a RESTful endpoint. Agree? You will have a bunch of queries, you will have filters, you will have all of that, right? Which in principle, what you're actually doing, you're diluting the purest way in some form or other, right? You call that an ad hoc request. And what does the client do on the client side, right? Some kind of a transformation. It'll slice and dice, it'll pretty much end up doing what your joins are doing in the server side. I have this endpoint and another endpoint. I need to join, I need to enrich the fields and all of that, right? You agree? Okay. So this is the pain. The pain is that if I want to paint a simple UI where I say I'm a user, I have this profile pic, and I have this many number of friends, for you to paint that, you will have to make at least like 5 to 6 REST calls. You have to slice and dice your data, and then you have to paint. So there is an inherent chattiness involved. There is a possibility that the server is giving you more than what you have asked for. And this unwanted data is waste, right? And if you're talking about mobile, waste of data and all of that. Okay. And so you can ask, this happens in the real world. In the client server, the client exactly asks what it wants, and the server actually gives you back, right? Can you have that? Right. So just the history behind. So this is the same challenge Facebook had when they're moving away from their HTML-based net, friends feed in the mobile. When they wanted to implement a mobile feature for the friend feed, this is the same challenge they had. They wanted to, make this whole thing based on REST, but they felt like, I'm going to make extra round trip to the server. I'm going to get data that I don't need, and it's all going to be costly in the mobile scenario, right? And hence, is there a different way in which a client can express what it wants to a server? And that is, so they since 2012, this is in production, but only a couple of months back, this has been open sourced, right? So what is GraphQL? GraphQL is a language, right? If you have two systems and they are a client and server, they can also be server and a server. If you need to express in a concise way, you can do that in a GraphQL, right? And the GraphQL provides you a language to express your need. It gives you a type systems on top of it, right? Does it sound too abstract? I see like a lot of blank faces. Are you with me? So the pain points, are we clear what problems that we are trying to solve? Yeah? Okay. So you can read the spec. So you have types, queries, interfaces, and different semantics for you to actually implement GraphQL. So I don't want to bore you guys with the spec. So I had this one example. Let's say if, can everyone see the JSON that we want? right? Say, let's say if this is the JSON that the client ultimately wants, what if I strip off the data part and say, okay, this is my request to the server, fill in this template and give it back. Right? There is nothing groundbreaking new in this, but I don't think we are doing that all along. Right? We will describe our request. There is an implicit contract between the client and the server, and then the server gives that contract back, as opposed to you give that responsibility back to the client, let the client describe the shape of the data it wants, then the responsibility is with the server to fulfill that request. Right, so what if I want to request, what happens, I need one specific user. You can send parameters, right? That's all right, but the thing with the UI is inherently hierarchical, right? It is reflected in the DOM that you have implemented. It reflects in the way you have structured your components. So what if I need to have like associated fields as well, right? And that's how you will express it. Like friends have few fields. I want to have them along when I'm requesting for the user. So far, okay? Right. So then you can say that, oh, I'm repeating multiple things. You know, user has ID, profile, picture, and all of that. And friend is also a user, but I have to, request all those fields again. So you can compose as a format. Fragment lets you do that. So basically, another need that you have in the UI is that if it is hierarchical, you need a way to compose. This is not possible when you had REST. Let's say you had 2-3 components. If you have to bash them, you can't simply easily compose them and then say one request at a time. And then it is up to the client to actually take it back. With graphs, because you're expressing your need in a structured way, you can actually make each fragment compose each other. Good?
Earlier in the REST world, it should have been 2 different REST services. Right?
Correct, which would have been chatting,
Right.
which is what you're trying to avoid. Okay, so what is happening is that you will have types which you are not having before, right? Also, you can express relationships. Let's say that friend is linked to a user. You can express that in your request. So REST by definition is tied to an API, but this being a language neutral, you can implement GraphQL in pretty much anything that you want. You have GraphQL on WebSockets, on MQTT, anything, right? So it does not mandate any technology on the backend. It's just a thin layer which just describes how you talk to the client and the server. Right, so we are also talking about attributes, right? So I have a user, I also need these many attributes. Let's say in the REST world, if I need a different set of attributes, it should be a different endpoint, which need not be a case here. I mean, I'll explain that in the demo. And you can also introspect. If you're exposing a GraphQL endpoint, any client can understand what is the schema that you're exposing, right? That is actually built into the system. And the last is, like I said, you can have a control on what is the shape of the data the client wants. Let's go. I'll come to this later. Okay, how many people are comfortable with the JavaScript on the server? All right, so, okay, so, Right. So in GraphQL, there are actually 2 types. You can either have a query which roughly relates to I need to read something, and you can have a mutation which basically means you're going to upsert. Right? You can only have these 2 types. the confusion of get, put, post, what is a post, what is a put, all goes away, right? You can either read or you can mutate data. Those are the only two operations about it. And what GraphQL expects you to do is that, so if you import the GraphQL system, there is a way for you to express your schema, right? So you basically say, this is my set of queries and these are the set of mutations. And if you, let me just, okay, so this, this is a React.js app, which basically says in your development mode, when you're building and exposing a GraphQL, you can enable this to be true. What this will give you is an ID in your browser. You can write your GraphQL queries here, or if you don't know what kind of things are supported, it actually automatically gives you a documentation saying you can have a support for a query and a mutation. There are two queries possible, and each of them, let's say, all I have is events. So if I am requesting for an event, it will actually go fetch and give me the data that I want. Let's say that what gets interesting, if I want to have more fields, this is not a different endpoint, it is the same endpoint. It's going to fetch the extra field that I've requested. You can see that. And you can also say, okay, so if I want, so basically there is just one endpoint on the server side and all the read goes to the same endpoint. You express what you want in the input, and the same will be returned as the shape of the data. Questions so far?
This is the next generation of web services. You can classify that.
So this is, so when you are developing in a way that where you have limited with the functionality that is given in your REST, this is, I won't call as a next generation, but the push is towards, if you're talking to a mobile where you're constrained with all this, this is one alternative. The reason it's not going to disrupt REST in a very big way because it's very, very new. And there are not many people using this.
This chatness is where it also enables some decision making. Right? I have the first REST request. Based on that, the client makes some decisions, either based on user interaction, and then it requests for other REST. So my question is, does it not make such decision making shift from the user interactions to some other people?
Yeah, true. So those are not going to go away. I mean, we're not, so this is more of if you have a page to load, and for page to load it involves 200 calls to make, you don't do that. But if it involves a decision making that I have to call that, is he authorized, if authorized, do that, that is still going to stay.
The second question is, again, I don't know so does it make the concept of microservices, backend for front-end concept of this kind of
No. So we are not, okay, I'll go there. In the typical world, in the typical REST world, you will have a REST server and a REST client, and you will have a chattiness and you'll have a data back. All we are saying in the GraphQL world is that you will have a GraphQL server which understands your request that is coming in GraphQL, and it knows the type system. There is a reference implementation in pretty much all languages right now, like all major languages. And then the response will be there. What is behind the GraphQL server is your same. If you have had microservices, it will be the same microservice architecture. So that is another reason, right? So if you have invested in your backend technology and whatever architecture you have, this is not going to disrupt that. If the biggest advantage is that you can drop GraphQL on top of it, and you can avoid the chattiness You can avoid writing new endpoints for a similar but not so different requests. All that is going to go away.
Won't it stop the caching?
Yeah, so that's the main thing, right? So if I go back, I don't think you will have caching for URLs like that anyway, right? So if you're, I personally believe that the caching part of REST is kind of overrated. Most of the time, you will end up something in your query params which totally knocks off your get cache, right? But there are frameworks on top of GraphQL like Relay which will give you a cache. But GraphQL by itself, everything will be pretty much a post. You can still, you're the one who's actually implementing the backend service, right? If you think I need to go via get, you can still do that. But that's going to defy the whole purpose, right? There is no, cache. There is a layer on top of GraphQL that will give you that cache, but not by itself.
In this case, how the client is understanding the scheme actually? Yes, there are some conventions, so you know, okay, what call to be expected or what call.
Yeah, so, okay, let me go back to the code. Okay, so I'll just start. If people are not familiar with JavaScript on the server stack, you will pretty much need a couple of libraries for you to get started with GraphQL, right? If you are writing a backend on a JavaScript, it is high time that you embrace ECMAScript 2015 or otherwise known as ES6. If not, you will be writing a lot of verbose code. So you need to know Babel. Babel gives you an ability to write an ES6 but still use the existing implementation. So Facebook comes with reference implementation of GraphQL server for Express, right? So you need that plugin. You also need, so what you're seeing here is called Graphical, which is another which is just a React.js app. You need that. So once you have set up your server-side app, all that you will be doing is you will be writing your API as a GraphQL object. You have like a user or a book, right? All you will be doing is you'll be writing them as your GraphQL object types, and you will describe, what fields it is actually exposing to you. What it also gives you is you will have a control on how, if this field is requested, how am I going to respond? Am I going to call a RESTful endpoint, get the data and send it back, or am I going to write query the DB and get the data? So you're still in control of how you actually service the request.
So it will be like that. It could be a responsible example like error code, etc.
Mm-hmm.
How will you manage it?
Okay, so because you're expressing your need in type systems, there is a much better error checking. For example, if you are giving something that is not known, it's going to crib. So cannot find query, right? You will have all of that. So because this doesn't happen when you are expressing in a RESTful way, is that there is no way for a server to validate what is coming in, right? But if you express your expected object as a type, there is a validation that is possible, that is out of the box. Okay. Right, so you can have a mutation as well. Mutation by design changes data. So if you want to update something, let me see, add event. Okay, so that's gonna. Yeah. So that's gonna update. So that's my insert statement that is getting fired. So you can basically have a read and a write with an expressive way, right? That's pretty much. Right. Right. Yeah. So if you, I mean, I can share the code, but basically, what you do in the client, you can express your queries and mutation, and what you do in the server is that you need an implementation of GraphQL in the server, and you have that in the Node and Java and Express. You can have that. So this is basically you will be the architecture if you're putting on top of microservices that you have or any infrastructure is that your GraphQL server will sit in the front of the RESTful endpoints. The client and the server will talk in GraphQL, whereas in the backend it will make a REST call or a DB call and then service the request.
How was the performance of the load balancing issues?
So,
Anything?
so this is still a HTTP request. Anything you can put Nginx in the front, HA proxy in the front, that's all the same. What is changing is that what goes in the wire instead of a plain object, now you have a types and that can be passed and understood by the server.
So I have used Facebook Graph Engine. It's amazing to wiring friends of friends, and all of this from Facebook Graph Engine.
Correct.
Coming to the point, do you have any comparative chart with GraphQL with Neo4j? So Neo4j is pretty much doing the same thing.
Okay, so GraphQL has got nothing to do with your graphical database engines or anything, right? So the question itself, I would say, is wrong because the word graph is the only thing that is common between Neo4j and GraphQL. So Neo4j is your hierarchical storage engine. You can still have that in the backend. What is GraphQL is if you have implemented a client which is using Neo4j in the backend, how is the client talking to the server? Is that through REST? And then in the REST endpoint, you will have an implementation that talks to your Neo4j. Right? So take the graphical representation as a, so it's only the way in which you talk to the server, and beyond that is all the same. If you have Neo4j or a MongoDB or a Postgres, does not matter.
How about the front end? Do they supply library for the client to talk to the graph system?
Right. So there are implementations in JavaScript that actually parse this and actually make it as a JavaScript object and send it over the wire. Right. That is actually transparent to you. That is one of the reasons why you need to include a few things on the server side when you're doing on the server side. Same happens on the client side. There is a GraphQL library that you will take it, which will know how to parse the new language, which is GraphQL.
So every request is a post request.
Typically, yeah, everything will be a post, and there will be just one endpoint on the server that will be listening. So this is the entire API that is actually powering it. There will be one endpoint. If you create an instance of a GraphQL Express server and give the schema, it will do everything for you. So the actual work is inside the resolver function for each field, right? For example, so here I'm using SQLize, which is like an ORM in JavaScript. So it will actually say, whatever arguments that everyone is asking, it will actually go and fire a where clause given that argument. And you can control what has to be parsed and all of that because you can control that. It's not like I'm opening my server for any kind of an argument exploit. You can pretty much say these are the two arguments, these are the types that it can allow, and you can control SQL injections and things like that. So,
how does this affect the deployment scenarios? Load balancing.
Yeah, so it is still HTTP if you have implemented on HTTP. If it is on WebSocket, it is the same thing. What goes inside is what is changing. So
Only you load balance based on the URL.
So if you're saying that something / goes to this server, you can't pretty much do that because it's all one endpoint.
Does it contain any state?
No, the language does not give you like a state. No, it's up to your app. So if you're So it is on, think of it like if you have used a protocol or a thrift or anything like that, that makes you interoperate with two languages, like it is similar to that. It's only a language for you to talk. If your application is inherently stateful, it will be stateful. So if you have a shopping basket, the way you talk to the shopping cart is what is changing. If you're keeping a session store on the backend on your whatever server that you have, it remains the same. It's not going to change.
Does the client maintain a schema, corporate schema, and associations and stuff? How will it know how to what column?
So
Where does it?
client does not store. It's like saying today I have a Facebook API. Do I know all as a client? Do I know all the intricate details of Facebook API? No, I don't. It is the same. But if you are asking me, is that as a client who doesn't know the contract, can I introspect and do it? Which you can. For example, this app is a client which just talks to my server and knows what schema it has, and it can actually understand there are two queries and two mutations that are supported. So introspection is built in. If you are exposing a GraphQL server, you can introspect and say what operations are possible, what types are exposed, all of that is possible.
So, is there an equivalent of ATOs like concept which is present in this? Because the exploration gets easier when you use ATOs based.
Correct. So, which is true, you will have, ThoughtWorks Martin has blocked that it's levels of RESTful adoption and your level 5 is ATOS. So that is given out of the box here. There is just, that's another thing, there is just one representation of GraphQL, there is no confusion, what is REST, what is not REST with this.
From a layman's point of view, this is, can I say this is more of a language improvement of REST? The REST spec, you have one more layer of on top of it. And
so the RESTful intention of the original paper and the way that we use there's a huge gap, right? Can you say it's an improvement on top of it? I would say it's an alternate choice. I wouldn't call it an improvement on REST. Where it improves is the side effect of exactly describing your need, right? Chattiness goes down, your shape of the data, you can expect exactly what you want and get that. Those are the things. If that's an improvement over REST, yeah. If you see it from that angle, yes. Okay, so GraphQL is just a language, and the thing about languages, you need some good framework implementation on top. So again, there is a library called Relay. What it does is it actually adds a lot more flavors to GraphQL. Things like if you are building a responsive mobile app, if you are making a post or making any action and the server is busy, you want an immediate feedback, what people call as an optimistic update, right? You make an update request, but you assume that the server will accept the update, and you can immediately guess what should be the result, and the UI gets painted, right? So Relay has framework to support all of that. It gets tricky when you have 2 or 3 optimistic update and something in the middle fails, right? Your app will go in an invalid state. And are you guys following? So let's say I'm doing an action, I'm assuming it's going to be accepted by the server. I'm doing a second action that depends on the first action. I'm also going to assume that is going to succeed. Now the UI does not know if the first request came back with a failure. Does the second request is correct or not correct? Right? So if you are having an optimistic framework and updates like that gets tricky. So Relay solves all of the problem, right? So he gives you a queue and auto rollback of optimistic updates and things like that. It is out, but my take is it's a little more complicated. GraphQL makes sense and you will pass your litmus test if it makes sense about the way in which you ask the data and that is what you get. That's pretty much GraphQL, but that's not the case with Relay. Relay is a little bit more difficult to grab. Have people used Redux before? If not, I would encourage you to actually see if you are anywhere touching a React Chase app. I don't think of any reason why you should not be using. There is a lot of this happened like 2-3 days back. There is a React.js conference, and people are confused. Okay, you are giving me React, you are giving me Redux, and there is Relay that's coming on. Which one should I use for what? And the talk is still not out, but I got this image. So if you are starting out fresh, you can start with a plain React, but your application complexity grows, and then right, it's up to you to choose between a Redux or a Relay. Right, so there are still open questions, right? So you can imagine like someone was asking, I can express relationships. What if I come up with a query that says parent, child, and child has the parent, and I keep nesting, like say 100 levels deep, and I have this query and then fire to the server. Server has to respond, right? It does not know the shape of the data. Nothing is like predefined as in REST case, right? So what will happen in GraphQL is that server will think this is a legitimate request and will try to answer. And if you have a denial of service on top of this request, it's going to be tricky. But then it's all up to us how to stop DOS. And if you, let's say there are arguments to say if you are implementing the endpoint, you should know what level of depth you have to answer to. And caching is not like a solved problem. People are solving it with Relay, but as a GraphQL is actually all of the benefits of get and in the rest goes off. Those are the things you still have to watch out. And I personally don't know how my schema file is going to evolve if my whole of the app has to be expressed in a read and a write, and all the endpoints has to go in. I don't know how it's going to actually evolve and how we're going to organize the file. That's something that to watch out to. So these are the bunch of things that you can refer, and that's pretty much what I had.
Does the mutation support update?
Yeah, it does.
How do we say that the update is in a way?
Right, so you can control that when you are expressing mutation. This is your mutation. You can pretty much say what does it that you can update and what you cannot update. You can do all that. So all that is your resolve function, right? So whether it goes to a DB or as a REST call is up to you to call. I mean, GraphQL does not impose anything. Any other questions?
Since
Yeah.
it's just going to be one endpoint, does that mean we can use both GraphQL as well as a REST endpoint?
Yeah, you can. Nothing stops you. Let's say that. So this is your Node.js server. So I can say some other thing is. This is user and one, and then say you implement. I mean, you can mix. Let's say as an app, I need to express both REST and GraphQL. You can do that as well. Yeah.
It's just pass the user is coming in and give it your
I think it's just a logical separation. If you actually ask me, there is nothing different. Both the query. So let me go back to the API. So this is a mutation, and this is a query, right? Both of them are GraphQL objects. So this is going to be a list of a GraphQL object, and the other one is going to be of type event, right? So in the end, both a query and a mutation is a GraphQL object, but just that you are exposing, the whole intention is it's meant for the product developer to say which is a read API versus a write API. And also another principle to say that if you are exposing a server, you need to know which is getting used where. And I pretty much need to know what is a read and what is a write.
Well, you mentioned something about the worker. There are 3 REST services which needs to be updated within a single job. What if the third one fails? The first 2 get successful. Third one fails.
Oh, that's on your backend, right? That GraphQL is not going to solve. So see, if your question is, if I have 3 RESTful endpoint here, I can't help it. This is beyond GraphQL, right? What is now available in Relay, which is an abstraction on top of GraphQL on the client side, is that if you're making 2 or 3 optimistic updates, it will give you an automatic rollover, right? So if the first call failed, it will automatically undo 2 and 3. That is what will go. But if your backend is having a 2 or 3 endpoint, one of them fails, it's up to you to implement it.
Object-fuel more appropriate name also in India. More of object oriented. Am I correct on that sense?
So, so they want to say that your DOM, your browser is a graph, and they want to shift the focus from the traditional set and way to the graph. I mean, you are expressing the reason why it's still a graph. And okay, if you think of object as having a graph inside, maybe yes. But what basically you're expressing is the graph of your dependency. Right? If your dependency is an object graph, then it's an object QL.
In general, like we'll address through REST calls, through URLs, this cause issues, right? We do reverse proxy, right? So, through this, how do we solve it?
You can. That's what I'm saying. You can still have a HA proxy or an Nginx here. It's still an HTTP request, so you can still have that.
So right now you're saying like we'll have a single endpoint, correct?
Correct.
So a single endpoint will come with a schema. I mean, there will not be any change in the URL. Correct?
No, don't make that assumption. It depends on how you actually send. Because internally the library can decide to send it over a wire. So internally, if it is HTTP, it has to be get and post, and nothing changes. You can decide that this is a post, and the GraphQL goes in the body as opposed to the URL. That is still controllable. That's why I'm saying don't take that for granted. That it is always going to be body. You can still make it a get and go via the URL. But what gets sent is an output of a GraphQL compiled into JavaScript or an equivalent. Okay. Any more questions?
Just one question.
Hmm?
I'm just curious. You have used tool Graphite SQL with GET requests. Is that intentional or like was that your specific use case? I mean, you could have demoed through post requests also, but mainly you use GET requests. So
Oh, okay. So this is
that intentional?
no, it's not intentional. I mean, you could. So that part, pretty much that like what I'm saying, right? Pretty much you will always end up using post. Yeah.
They want to solve the chattiness.
Mm-hmm.
And still, are there any alternates to GraphQL at this point?
Oh yeah. So I had that in the slide. So let's say. Right, so this way, right? So this is the way. So you pretty much can do what GraphQL is doing today with REST with JSON API, right? And there is a spec, there is a way how to do that. You can look it up. So what it basically says is, I want this user 4000. I don't want 100 fields that the user has. Just give me an ID and the name. And I want the profile picture, but I don't want any profile picture. I want profile picture of size 50. You can do all that. This is REST. This is your alternative. If you don't want to embrace GraphQL, you can look at JSON API.
Basically, it flattens all that and puts it like this. Right?
Yeah.
No, I'm not. This is fine, but I'm asking in terms of alternates in the sense GraphQL alternates, just like Carba versus RMI.
Okay. So GraphQL itself was released like, I don't know, 6 months back. So as an alternate to REST, you just have one candidate right now.
So it's not introducing any more latency to the overall, because see what's the actual drawback if I'm going to have a chattiness, if I'm going to use a REST API. Okay, and then if by introducing this, of course, chattiness is reduced, of course. But are we not introducing some more layers, which in turn will introduce some more latency to the overall transaction?
Right. So if you're talking about performance, you will take a hit because there is one translation layer. But what you actually save is the client side chattiness, right? Which is what is costly. I am on a mobile and I'm paying for data. I'm limited in my bandwidth. That is what you're trying to solve. Does it mean I have to have some more compute power on my server because there is one more layer before hitting the real layer? That's very marginal that you can control from the server side. And the implementation is kind of very thin.
What was use case to go and try graphic use case and lead to graphic?
It's so if you have implemented microservices and you're also seeing the UI part, you will have a frustration that just to paint a simple small part of the UI, you have to hit like hundreds of things and do aggregations and all of that. It's just that frustration.
You want to use graphical, or you find a situation where graphical is needed for your application workload?
Yeah, this is exactly the need. And if you can express what exactly the client wants, and if server can serve that, that is like probably better than saying I will generate. It's if you translate to the real world, if you are in a restaurant, you're ordering for something, you expect the chef to do what you want. Instead, he gives you a hot water, he gives you a rice. It's similar to that, right? That's pretty much what you do in a typical restaurant client side setup. It's just that frustration is that can you not do this?
So the problem for Facebook, right? So that's what
If you implement any serious application, and if you were going full stack from server to all the way to the client, you will face this problem.
what about small companies and small applications?
Yeah, it's not a silver bullet at all. I mean, this is just that if you are thinking of trial assess and adopt and all that in radar strategy, this is like assess. There is a new thing out there, you try what it can offer. Okay.